In this video, we will learn how to prove two triangles are congruent using the side angle side congruence test. Before that, let's quickly recall what we mean by SAS. Well, notice that the letter A is between the two S's. This means that the angle is sandwiched between the two sides. We call such an angle an included angle. So, look at these three triangles. Which of the following angles is an included angle? Between these two sides, or these two sides, the angle given is not sandwiched between the two given sides. But between these two sides, we have an angle of size 58 degrees. So, 58 degrees is an included angle. We are going to use this idea of knowing two given sides and an included angle to prove two triangles are congruent. Let's look at our first problem. We have two triangles, FGH and XYZ, with these lengths and angles. Our task is to prove that the two triangles are congruent. This means we need to identify a set of properties to explain why triangle FGH is congruent to triangle XYZ. How do we start? Well, let's first consider what information we are given. We know that the length of GH is 7 centimeters, and the length of its corresponding side, YZ, is also 7 centimeters. So, one pair of the corresponding sides is equal. Do we have information about any of the other two sides? Well, we also know that the length of FG and its corresponding side, XY, are equal. This means that another pair of corresponding sides is also equal. Now, are we also given information about these last two pairs of sides? Notice that no information is given, and we are also not able to find it with what we know. So we can't use this pair of sides. But how about the angles? What do we know about these two angles? The size of the angles is not indicated. But if you read the problem again, notice that we are given that angle FGH is equal to angle XYZ. So, one pair of the corresponding angles is equal. And notice that this given angle is an included angle. It is sandwiched between the two sides. Therefore, triangle FGH is congruent to triangle XYZ by the SAS congruence test. This means we can now conclude that the length of FH is also equal to XZ. Now, let's take a look at a slightly different problem where we have to now identify the congruent triangles. First, let's understand the problem. Here, we have a figure where AOC and BOD are straight lines. We are also given that the length of OA is equal to OC. For ease of reference, let's mark them as equal on the diagram, okay? We also are given that the length of OB is equal to OD. So again, let's mark them as equal on the diagram. What we want to do is prove that triangle AOD is congruent to triangle COB. Notice that we are only given information about two sides in each triangle. So first, let's write down what we know of each triangle. We are given that the length of OA in triangle AOD is equal to the length of OC in triangle COB. We are also given that the length of OD in triangle AOD is equal to the length of OB in triangle COB. We only have information about two sides in each triangle, but we need one more piece of information, either about the last side or the angles, to be able to prove the triangles are congruent. While it is very tempting to say that AD is equal to BC, because ABCD looks like a rectangle, remember, we are not told or given any information whatsoever that ABCD is indeed a rectangle. So we cannot assume that the length AD is equal to BC. What can we do next? Well, let's consider the angles in both triangles. There's one pair of angles which are equal. Can you tell which pair it is? Because these two lines are straight, These two angles here are actually vertically opposite angles. This means that angle AOD in this triangle is equal to angle COB in this other triangle. And since the angle is an included angle, triangle AOD is congruent to triangle COB by the SAS congruence test. And you can actually do the same to prove that triangle AOB is congruent to triangle COD as well. Got it?